I'm going to give you some hints on this one. I'm not necessarily going to give you the answer. This angle right here, of course, is going to be the inverse tangent of vertical over horizontal, 3 over 2. Gives you 56.31 degrees. This angle right here is going to be the inverse tangent of 1 over 6. Again, vertical over horizontal. Second tangent, 1 divided by 6. And really it's opposite over adjacent. The 1 is the opposite side. So it's 9.46 degrees. Now because of that, of course you know this one over here is also 56.31. So because of that, you know this is a right angle, so you can find this angle by subtracting from 90. If you cut this down here, you know this angle, right? From that, because it's a 180 degrees for the whole triangle. So then you'll know this angle here by subtracting from 90, the two of them from 90, right? So now you've got those angles. Because you know those angles, if you extend this out, you can find this angle, because that makes a triangle there. So this is just the third angle of that triangle. Once you know that angle, you know that these are right angles because those are tangents to the circle. And you know that a four-sided figure adds up to 100 or 360 degrees, right? So you know that angle and you know the two right angles there and there. You can find this angle in here. Now once you have that angle right there, that's where the whole key of this lies. You use that angle to find in this triangle this length and this length. Once you have those lengths, the rest of the world falls into place. Because then, of course, you'll know this length here because you'll just subtract this one from the 10, because it's a 10 millimeter radius. Does that help you guys get started on that one? Okay. I'm going to leave it at that because I want you guys to keep working on that. So anyway, let's take a look at number 2. X, Y, and area. Yep, total area is listed. So you have 48 millimeters here and an 88 millimeter diameter. I wanted you to find, and this is a 1 to 4 slope. I wanted you to find X, which is the total height, Y, which is this width, and then area. So here's what we're going to do is we're going to connect this across here. That length of that blue line is Y. And then now I'm going to take that and I'm going to cut it straight down here at a right angle. Because this angle here can be found using the 1 and 4. Which one is the opposite? If I do an inverse tangent here, which one is the opposite side? The 1. So it's 1 over 4. Second tangent, 1 divided by 4, 1404. Okay, now that tells me this angle right here, by the way, is how much? Yeah, so 90 minus 14, that one's going to be 75.96 degrees. This is 90. But this is also 90 here between the radius and that tangent. So that means this here, this angle, is 14.04. There and here. So you can use that to find this angle up here. You know this here is 44, right? 44, right? Once you have this angle here, y down here, y squared is equal to 44 squared plus 44 squared minus 2 times 44 times 44 times the cosine of whatever this angle is in here that you found. Like 161.92, something like that. Law of cosines. Once you know this side here, the rest of the world falls into place for you. You have this right triangle here. You can find this length by subtracting the 48 out of the middle, and then equal parts to each side. Because you know the angles then you can find this length from your just basic right triangle trig. And then here's the one little trick you might need to know. Take this one and divide it like this. So then you can find this length right here, because you know this is 44, and this is the right angle, and you know this is 14.04. So you can find that length. Once you have that length, you've got this length, and then the radius add up to make x. And the area you guys can do pretty simply from there. You'll just have triangle, rectangle, equivalent triangle, another triangle, and an arc of a circle. So it's not so hard. Good enough hints? Cool. Okay. Well, let's hit our new stuff for the day. Something new. Not really, no. Yep, times the cosine of whatever that angle was at the center there. This is what we call a frustum. Frustum, yeah. For some reason, whenever I say that, I want to say frustum nearly killed him. Anyway, a frustum is actually a piece of a cone or a pyramid. This one's a cone. Because for you guys in machining, things tend to go around and around when you're turning stuff. This is basically a taper for you guys, is what it is. So we're going to do this. We're going to take the bottom here, and we're going to give that a diameter of 120 millimeters. We're going to take the top here and give that a diameter of 80 millimeters. We're going to give this here a height of 90 millimeters. I want to find the volume of that. Technically, the only way to find the exact volume of this is to find the volume of the whole cone and subtract off the volume of this little cone. Let's do that. And then I want to see if we can find an easier strategy that's close enough. So the first thing we got to figure out is how tall would that whole cone be? Well, we can do a taper angle by cutting this right here. What's this taper angle here got to be? Well, what's this length down here have to be? 120 minus 80 is 40, right? Half goes each direction. This is 20 millimeters here. There would be 20 millimeters over here too, right? Does that make sense? And of course, this is 90 millimeters. So this angle here is the inverse tangent of what over what? 20 over 90, opposite over adjacent. Second tangent of 20 over 90. 12.53 degrees. Does that make sense so far? So then, let's figure out how tall this whole cone would have to be. This, of course, would have to be 60 now, right? 60 millimeters. this angle would still be 12.53 degrees. Yes? So, tangent of 12.53 degrees equals 60 over h. Put this over 1, we're going to cross multiply and divide. So we got 1 times 60 is 60, divided by the tangent of that previous answer, that 12.53 degrees, gives us 0.70. That is not correct. 60 divided by tangent, not second tangent, 12.53. That should be better. 269.97 sounds better. Millimeters. Everybody see where that came from? Okay. So the volume of that cone comes from the area of the base. Let's find the area of the base. The area of the base down there is pi times 60 squared. Does that look familiar? Pi times radius squared? Area of a circle? Sure. That's fine. So I've got pi times 60 squared. It's going to be 11,309.73. So that's millimeters squared. That's an area for the circle. So that means the volume of the big cone is the area of the base times that height. And because it's a cone, it's divided by 3. So it'll be that times 269.97 divided by 3. So there's our volume. Ugly as sin. So what do we have there? 1,017,000. So 1017. 762.92. In millimeters cubed. That's the volume of the big cone. So next we need to find the volume of the little cone. The base on the little cone, that has a diameter of 80, so it'll be a radius of 40. So the area of the base of that is pi times 40 squared. Second, pi times 40 squared. So 5,026.55. Then it's going to be for the volume of that small cone. It's going to be the 5,026.55 times its height. I've got to take this minus the 90. So that'd be 179.97. And over 3. So that times 179.97 divided by 3 gives us 301,542.63 millimeters cubed. So now we just have to subtract those two. 1,017,762.92 minus 301,542.63. We get 716,221 .29 millimeters cubed. So that is the volume of that frustum, or that taper. But I want to take a look at, would there be an easier way of getting an answer close enough to that? Well, when we did like trapezoids, we took the average of the bases and multiplied by the height. So one possible approximation of this is take the average area of the bases So what do we have for area of the bases? We had the 11, 309, 73. And we had the 5, 0, 2, 6. So if we add those together and divide by 2, and our height was 90, right? Let's see what we come up with. $11,309.73 plus 5026.55. Now, since I didn't put in parentheses, I have to equals before I divide. Divide by 2, then times 90. That was. See? So I get 735,132.6. Not the right answer, is it? How far are we off, though? And here's the thing. We are off. The percentage that we're off. Why are we off? Well, because a trapezoid is 2 dimensions. Here, basically what we did is we said we're going to cut this like this and take this piece and flip it up and put it in here to make this into a cylinder. The problem is, because this is 3-dimensional, what's on bottom here is bigger than what's missing on top. It's further around the bottom than it is around here. So it doesn't quite work that way. So it makes sense that our estimate's off. But how far? Well, what we're going to do is we're going to find a percent error. Remember doing this from last semester? Percent? Percent error, we start with the absolute error. Absolute error is just subtracting the two of them. So we're going to take the 735 minus 716,220.29. So we have an absolute error of 18,912.31 millimeters cubed. Do you remember how to turn an absolute error into a percent error? Or relative error? We're going to divide by this actual value here. So we're going to divide by 716,220.29. 0.0264. So we're going to change that. We'll remove the decimal point and make it a percent. It'll be 2.64%. So the big question is, what are we going to use this for? Over your actual value, which is this one. No, the real answer, the exact answer. So if we're just trying to do an estimate on materials for a bid, this would be fine. We would just go ahead and use that. Yep, that works. That's just a complicated formula for it. Yeah, that works. That R times R is your adjustment factor for the difference. So anyway, if you use that formula, you should come up to really close to the 716. 715,920, yeah, that's close enough. Does that one have use pi or does it use 3.14 in it?
Use pi, but I use 3.14.
That would make the whole difference right there.
Difference would be one.
Here, let's. Bruce has a formula in his cheat sheet for the volume of a frustum. What is your formula, Bruce?
It is pi times height times r squared.
Oh, give me a second. Pi times height times.
Large base squared plus the small base radius squared plus the small base radius times the large base.
Like that?
Over 3.
Over 3? And it's like this, isn't it? Kind of like that?
No, the pi and the h are in there too.
But they multiply everything on top, right? There's parentheses around that? Let me see.
Well, yeah, there are parentheses.
Yeah. It doesn't matter where we put the over 3. Okay. So it's like this is the way his is listed out. Okay. So let's go ahead and do this. So I'm going to use the pi key times my height of 90 times parentheses. What was my big radius? 60 squared plus 40 squared plus 60 times 40. And I know they use parentheses, but we don't need to. Divided by 3. 716, 283. We're really, really close. There's some round off errors in here because of the trig and the angles. Yeah. So that formula is a formula if you memorize it. This here, basically, this is averaging the bases. This is that adjustment factor for the fact that the larger base is really dominating. So, I've got a new worksheet I'm going to give you guys for that. What's that, Richard? Yep. Yep. Well, it's radius times radius over 3. Okay. I'm going to give you a new worksheet to work on, and we'll give you the rest of the class. Here you got 22 minutes, 23 minutes to work on it.